Welcome to the next lecture on the differential equation. Today I will explain you the type third of the operators method. Myself Dr. Harish. You can follow my YouTube channel where you can find the playlist of the mathematics 2 differential equation. And you can see that the previous two lecture was on exponential forms and the polynomial form of the operators method. Now this operator method is used to finding the particular solution of the differential equation based on the nature of this fx, whether it's a polynomial, whether it's an exponential, or whether it's a mixture of them. Then we have discretized them. The first two lectures I have already uploaded. You must watch these lectures because today's lecture is totally based on these two parts. Now in this today's lecture we will see how we can solve when the function is the product of exponential and any of the other term. So for examples, if you look for these problems, there is a one exponential terms, product of them, exponential terms, product of them, and so on. How you can solve that is a very easy form. So firstly, as I told you in our previous lectures, how you can solve this component. Firstly, you can write this first quantity in the terms of the capital D of y is equal to x cube e raised to power 2x, where capital D is my d over dx, that's the operator. So can you find the value of the y from this case? Is a d square minus 4d plus of d x cube e of this. Fine. Now clearly say this part is my polynomial. I denote it as 1 over polynomial of the d. Once you can write this function, any of this problem in the terms of y is equal to, then the simple rule that I have used is 1 over polynomials into exponential. So you can take exponential outside and replace the capital D to capital D plus A. For example, I will explain you this with the help of the numerical examples. So I will cover the 10 examples in this lecture. So you have to watch this video till the end and don't forget to like and comment on this video as well. Firstly, can you write this equation as 4d square plus 4d plus 4 of y is x cube e raised to power 2x, where capital D is my d over dx. So can you find the value of the y? So therefore y particular solution is 1 over d square minus 4d plus 4. Fine. Then now since the quantity is written as a exponential and the product form, make sure this rule is apply only when it's exponential and some function of the x in the product form, not in the form of the plus or minus. Then we can apply this rule. What is the rule is? I can take exponential component outside, fine, and then replace capital D to the D plus A. Coefficient of x is my 2. So wherever the capital D is written, I can replace them to be D plus 2. Fine, this is plus 4 because exponential term is outside, the remaining part is only x cube. Fine, now you can open this bracket. Can I simplify this component? This is a square plus b square plus 4d minus of 4d minus 8 plus 4 into x. So what will happen? 4d will be cancelled, 4 plus 4 cancel, minus 8. So 1 over d square is the 5. Now what is the d is? D over dx. Then what is my 1 over d? That is the integration. So what is the meaning of this case? 1 is a d square, that means double integration of the x cube. So can you find the double integration of the x cube? What is the first integration is? X4 over 4. What is the second integration is? X5 over 5 into 4. So the answer is x5 over 20 is my right answer of this problem. Fine. This is only the particular solution. But if somebody will ask you solve the differential equation, then you have to firstly write the auxiliary equations. For this case, it's a m square minus 4m plus 4 is 0. Then your roots are my 2 comma 2. So therefore, your solution will be c1 plus c2x e raised to power 2x. And the final solution will be yc plus yp is my right answer. But anyhow, in this case, it is only written as a particular solution. Dear student, if you are new to my YouTube video, kindly subscribe my YouTube channel as well. Again, you can see this function e raised to power 3x into 1 over x cube. That's the product form. Fine. So firstly, I can write this in the terms of the capital D. D square plus 6d plus y plus 9 is equal to this. Can you find the value of the y? So yp is my 1 over 6d plus 9. I can take exponential component outside, e raised to power minus 3x is outside. I can replace to be d plus a. What is the a in this case? A is my minus 3. So I can replace them as a d minus 3 plus 6 times d minus 3 plus 9, and the remaining expression is 1 over x cube. I can open the bracket of this. Fine, you can open this expansion. So a minus b whole square, a square plus b minus 2ab plus 6d minus 18 plus 9 into 1 over x cube. So clearly says 6d will be cancelled, 9 plus 9, 18 is also cancelled. So expression is 1 over d square. So what is the meaning of the d square? That is my double integration of 1 over x cube. Fine. So what is the first integration is? Your target is to find the double integration. The first integration is x raised to power minus 2 over 2. Then the second integration is x raised to power minus 1 over plus 2. So that is the answer of this part. So it's my x raised to power minus 1 over 2. I can written x raised to power minus 1 is 1 over 2 is the 1 over 2x is the right answer. Okay, now look at that again. This is the product form and exponential term is present. Make sure student, if it is a sin x, then this rule is not applicable. This rule is applicable only when you have the exponential term present. So can you find the value of y? Y is equal to 1 over d square minus 3d plus 2. Then exponential rule is present. I can take an e raised to power x outside. I can replace capital D to the d plus a. A is my 1. So 1 plus d square minus 3 times d plus 1 plus of 2 into x. Fine. I can open these brackets. Once you open this bracket, what will happen? It is e raised to power x a square plus b square plus 2ab minus 3d minus 3 and plus of 2. So clearly say 1 plus 2, 3 will be cancelled. So the expression becomes 1 over d square minus into d. Fine. Now how you can solve that? Because it's a polynomial. So what is the rule for that? You have to watch this polynomial form lecture. What I told you? You have to make the series expansion either in the terms of 1 plus x or in terms of 1 minus x. So your first target is to construct them as a 1. Like that, there are the two ways. If you consider d square as a common, then it will be 1 over d. But it is a, what is the meaning of that? This is my d raised to power minus 1. But we always need a positive power. So this is not possible. I can consider the minus of d as a common. Then it is my this expression. Fine. So I can replace this numerator, this denominator I can written as minus e raised to power x 1 minus d of x. Fine. Then I can use the series. It is minus e raised to power x 1 over d is outside, 1 minus d raised to power minus 1 of x. Then I can expand the series 1 minus x1. It is e minus e raised to power x. Now you have to expand until the power up to the 1. So a 1 plus d square. Now it's the power more than of this. I can stop writing. Fine. Now you can open the bracket. What will happen? It is e raised to power minus x 1 over d. 1 into x. What is the d? D is my derivative. So derivative of the x 1. Second derivative is 0 and others are also 0. So this is my x plus 1. Now what is the 1 over d? 1 over d is my integration. What is the integration of the x? X square over 2. Integration of the 1 is 1x is my right answer of the problem. Don't forget to like and comment on this video. I hope you can support my efforts by liking and comment on the video. Again, you can see it's a product form. Firstly, you have to write in terms of the y. Fine. I can take e raised to power 2x is outside. Then it is 1 plus d square minus 1 into x square. I can open the bracket, which will be my d square plus 4d plus 4 minus 1 is my plus of 3. Fine. Now, again, it's a polynomial, so your required target is to make them as a 1. If you consider d square as a common, then it will be 4 over d. It's a negative power. So I can take 1 over 3 as a common. E raised to power 2x. I can take 1 over 3 as a common. Then it is 1 plus d square plus 4d divided by 3 into x square. I can take this value as a power. It's my minus 1. Now you can write this expansion of, how you can write that? It is e raised to power 2x over 3. 1 plus x is a 1 minus x. X is my d square plus 4d over 3. This is my x. Plus you have to write up to the power 1. So plus 4d over 3 square and then so. Fine. Now you can open it because it's only the power 1. There is no need to write the power 2. Only the first expression is enough. Now you can open this bracket. It is e raised to power 2x over 3. 1 into x, x minus. What is the second derivative of x? 0. What is the first derivative of x? Is 1 over 3. And that is the right answer. X minus 4 over 3 is the correct answer. Again, you can see it's a product form. I can again write the series as a y. So which I can find the particular solution is 1 over. So I can take e raised to power 2x is common. Then it is 1 plus d square minus 4 times d plus 2 plus of 3. You can open these squares, a square plus b square plus 2ab. You will get the expression, because if you open them, I will show you again if you want. Otherwise, that's a very simple calculation. It's a square plus b square plus 2ab minus 4 minus 8 plus 3. Now clearly say 4d will be cancelled. It's a 7 minus 8. That's a minus 1. Again, it's a polynomial. Then your target is to make them as a 1. I can take minus of the 1 is common. Then it is 1 minus d square of x cube. Then I can return 1 minus d square is the upside with the minus 1 of x cube. Then I can expand the series as 1 minus x. It will be 1 plus x square and so on. My target is to write only up to the degree 3. So since already 4 appears, I can stop writing. Minus e raised to power 2x. Dear student, if you want to know how this calculation appears, you have to watch my this previous lecture of the polynomial form. That will help you to understand how you can solve these problems. Now it's a 1 into x cube. What is the second derivative of the x cube? The first derivative is 3x square. Second derivative is my 6x plus the fourth derivative. Third derivative is 6. Fourth derivative is my 0. So answer is x cube plus 6x is my right answer. Again, look at this another one. Again, it's a exponential and the product of the sum term. So I can find the value of y. Fine. Either you can factor them, otherwise there is no need. There is no need of the factorization. You can also write the similar way. I can take e raised to power 4x is outside. Then it is d plus 4 whole square minus 5 into d plus 4 plus of 6. It is my x square plus 9. Now I can open the denominator expression. So it will be my d square plus 16 plus 8d minus 5d minus 20 plus 6. So the expression is d square plus 3d. It is my 22 plus of 2 into x square plus 9. Fine. Now your target is to make them as a 1. Otherwise, if you want to substitute d as a d plus 1, so it will be again e raised to power 4x into d plus 4 minus 3 and d plus 4 minus 2, and you will see the same result has obtained. But I suggested you there is no need to factorize them. You can directly substitute the value as I mentioned here. Now your expression will be here. Your target is to make them as a 1 because it's a polynomial. So I can take 2 as a common. Make sure, student, if you taken as a d square common, then it will be 3 over d plus 2 over d square, and clearly say these two terms has the negative power minus 2 minus 1, but we always need a positive powers. Fine. So how you can take that? I can take 1 over 2 common. It's a 1 plus d square plus 3d over 2 into x square plus 9. I can write this expression in the numerator with the power minus 1. Now you can expand the series. What is my series? 1 plus x raised to power minus 1, 1 minus x plus x square minus x cube, and so on. Since we need as x square only, so I can expand up to the first three terms. E raised to power 4x over 2, 1 minus x, this is 1 minus x plus x square plus 3d over 2 square up to so on, and the expression is x square plus 9. Fine. Now you can open this bracket. It is already open, it's not a negative. Now you can see that e raised to power 4x over 2 is a 1 minus, I can open this bracket, I can write this value as such. Fine. I can write only the power maximum up to the 2. If you use as a d square plus 3 whole square, the denominator will be 4. It's a d raised to power 4, but we need only as a d square plus 9d square plus 2ab. If you taken as a 2ab, it's a cube, but we need only as a power 2. So I can write 9d square by 4. Now you can open this bracket. It's a e raised to power 4x over 2. If I use them, it's a x square plus 9. What is the second derivative of the x square plus 9? First derivative is 2x, second derivative is 2. So that will be my 2 over 2 minus 3 over 2. The first derivative is my 2x plus 9 over 4. Second derivative of this is my 2, and so on. Now you can simplify that. It is my 1. This will be cancelled out. This will be my cancel out. And after the simplification, you will get the right answer as my this. This is the way you can easily solve this exponential and the polynomial terms. Quickly look at the another one. Find the value of the y quickly. Fine. I can take e raised to power minus x common. I can replace capital due to the d plus 1. But here is a is my minus 1. It's a d minus 1. Minus 4 times d minus 1 minus 5 of x. I can open this bracket, and those terms which are cancelled out we will see as d square minus 6d. Again, your target, because it's a polynomial, your target is to make them as a 1. I can common as a minus of 6d. It's a 1 minus d square minus d over 6. Fine, into x. So I can written as minus e raised to power minus x over 6 into d. I can written this value as power minus 1. Fine. Now you can expand the series. What is my series of 1 minus x raised to power minus 1, 1 plus x square, and so on. Because the degree is my 1, I have to write only the first two terms. Minus 6, this is 1 plus x. Fine. Now you can open this, sorry, it's a 1 over d also. So it's a minus e raised to power 6, 1 over d. It is x plus derivative is 1 over 6. Now what is the 1 over d? That's the integration. So you can find the integration of this part. So that will be x square over 2 plus x over 6 is my right answer of this problem. These 7 questions are exercise for you. You can try to solve it by yourself. You can see that each term involvement of the exponentials and the some other parts. And they are asking about the solve the problem. That means your target is to find the auxiliary equation firstly, and then you have to find the particular solutions with the help of the operators methods. And I am waiting for your comment whether you are able to solve all these problems in a very easy manner or not. I am waiting for your comments in the comment box. I hope you can like, share and comment on this video, and you can share this video with your classmates as well, and don't forget to subscribe my YouTube channel. Thanks for the watching and thanks for the support all this. Happy learning students, best wish.